All right, hi guys. This is our most daunting of our Punnett square problems. These are our dihybrid crosses. So I'm going to walk through how we do this. We'll see a word problem here, and then you want to make sure you're able to fill this in on your own if you ever need to. So dihybrid cross, this is when instead of looking at one trait that we've normally done, we're looking at two traits together. Okay, so Mendel did this with his pea plants. He looked at tall pea plants and short pea plants versus round seeds or wrinkled seeds. So he wanted to see how often that the dominant trait for both traits, tall and round, showed up in his giant sample size. So we're going to do that ourselves. And in this word problem, we have humans. We have free earlobes that are caused by the dominant allele. So I'll just go ahead and start highlighting anything I think that is going to be useful, big E, and attached earlobes by the recessive allele E. And then widow's peak is dominant, big H, to straight hairline, which is little h. And then what is the probability that a child from the mating of this guy, big E, big H, little h, and the same thing, parents will have a widow's peak and free earlobes. We'll hold off on that question about widow's peak and free earlobes. For now, we'll just put in our parent genotype. So this is one parent. This is the other. And they have the same genotype, and they're both heterozygous for both, right? So we don't need to get too much into that. But I already put in the genotypes and the phenotypes as options, right? Homozygous dominant, heterozygous, homozygous recessive for genotypes, and then phenotypes, free or attached earlobes, as well as widow's peak versus straight hairline. All right, so in order to do a dihybrid cross, there's a few ways to do it. But the way I'm going to show you involves having two other Punnett squares. Okay. And we're going to take these parents, and we're going to just put one in each. Okay, so we're going to put, for the first one, let's make these different colors. So this will be big E, little e, big H, little h. And then we'll put this parent over here, big E, big H, little h. So then we just go ahead and put it in like a normal Punnett square, though our letters are different. Big E, big H. And always try to keep it consistent. I'm always going to put the E first. That's going to really help you just stay organized. And then I'll go ahead and fill out this one. Okay, so once we transfer these to Punnett squares, we're just going to keep moving these guys. We're going to take all of these offspring and put them up here. So one at a time, like the top left one, this would be big E, big H. Right, top right one is little e, big H. Bottom left, big E, little h. And then last one, little e, little h. All right, we can go ahead and move this parent over here as well. So we get big E, big H, little e, big H, big E, little h, and then little e, little h. Notice in the dihybrid cross, everything is bigger. We have 16 squares instead of 4, and on each side of the square, we have 2 alleles instead of 1. And that also means in each square, or in each box, we're going to have 4 alleles instead of our typical 2 that we see in a monohybrid cross. So this is going to take a second. We're just going to, like for the top left one, we just do the same thing as a monohybrid cross. Just make sure you put your E's and different genotypes together, right? And we just kind of work through it. So this is the very tedious part. So if you need to like fast forward or anything, now would be a great time to do that. Kind of keep writing them in. We need to play like some Jeopardy music or something. Okay, so now that we're done with that, we can go ahead and start labeling our different ratios. So I'm also going to ask, or we're going to try to figure this out, and this kind of goes into phenotypic ratio. How many are dominant for both earlobes as well as hair? Then we're going to ask, so we'll put a number there, how many are dominant for ears, recessive for hair. Then we're going to look at recessive for ears, dominant for hair, and then our last one, recessive for both. All right, so you can eye this out if you want to. I'm going to highlight it just because it is a lot more helpful in terms of identifying. So we'll start highlighting anything we see that are dominant for both in red. So starting on the top left, big E, big H, that's dominant for both. Moving over to the right, that's dominant for both. And so are these two, right? Heterozygous, still dominant for both. Second row, yep, dominant for both. Next one is our first one that's not dominant for both, right, because it's recessive for earlobes. So we'll just skip that one for now. This one's heterozygous for both, so it's also dominant for both. And then the next one is not dominant for both. This one's also heterozygous. This one is not, because it is recessive for hairline, as well as the one to the right as well. And then our last row, dominant for both. Nope, nope, and nope. So we go ahead and we count all those up. We got 1, 2, 3, 4, 5, 6, 7, 8, 9 red boxes in our dihybrid cross. Okay. Our next one, let's do purple. We're looking for dominant ears, so something that has a big E in it, as well as recessive for hair. So anything that has little h, as well as dominant ears. So if we look at this one does not apply because it's recessive for ears. We need it to be dominant. Same is true for this one, recessive for ears. Looking at this one, big E, little h, this is what we're looking for. Dominant for ears, recessive for hair. Same is true for this one. We go to the next line. Recessive for ears, no. And then this one is. And then our last one, no. So we count them all up, and we have three offspring that are dominant for ears and recessive for hair. Our next one, let's do orange. We're looking for recessive ears and dominant hair. So little e, and big H. So we go here. This one is. Move over. This one also is. And we go to the next one. Yep. And then last one, nope. So we have 1, 2, 3 orange. So 3 that are recessive for ears, dominant for hair. And then our last one, recessive for both. We have this guy. All right, so this is our ratio. And we're not going to do the genotypic ratio because that's just too many options. But this is an important ratio for dihybrid crosses, 9:3 to 3:1. Because now we can look at it and we can answer the question, what is the probability of offspring that have widow's peak? So let's just go back to our word problem. Widow's peak is dominant, big H. So we're looking for anything that has a big H in it, as well, or dominant for hair and free earlobes. Let's go back to the problem. Free earlobes are dominant to attached. So we're looking for anything that is big E, big H, also known as dominant for both. So our fraction is going to be 9 out of 16. Let me just grab my calculator real quick, which we'll get as 56%. All right, so we have parents have a child, they have a 56% chance that their child will have a widow's peak as well as free earlobes. All right, so again, make sure you're able to understand what we're looking at here. I know it can be overwhelming as well as tedious, which is a deadly duo, but please be patient with it. Keep working through it. Let me know if you have questions, and I will talk to you guys later. Bye.